Here we have only defined the types of the load that we will be applying. We haven't yet applied any kind of load on our structure. In the dead load type, we got various types of load. So here we will apply the self weight first. Let us click on dead and then click on add. So from here you can define the various kinds of load that you want to apply. It is the dead load. The load that we are applying is the self weight or the self load, and the direction is the y direction, and the factor is -1, which means that the self weight of this structure or the structural member will be calculated by the software itself. So how it will do that? For example, if this is your beam, so this is the section of the beam that we defined. So this is 0.3 and this is 0.2, and the length of a beam is 5 meters. So its volume turns out to be 0.3 into 0.2 area of this cross section times this length, that is 5. So you can get the volume. And the unit weight of concrete is 25 kilonewton per meter cube. The weight is the unit weight. So let us see, this is gamma and this is V. Gamma times V, because 25 kilonewton load is contained in 1 meter cube of the concrete, which means that this volume of concrete weighs 25 times the volume. Alright, in this way the software will calculate the self weight of the structural members. Upward direction is the y direction. Okay, we got the weight and we have to apply the load in the downward direction. So the self weight must be applied in the downward direction, which means that we have to apply the load in the, so this is the origin, in the negative y direction. Okay, and so whatever the value we get, so we get this value, and if we multiply this with -1, we will get -25V of the weight. So -25V means that it will be applied in the downward direction. So that is why factor -1 has been taken. So if we take the factor as 0, then the self weight of this structure will not be considered. So that is what we basically do in our preliminary structural analysis of the beams and the frames, right? We don't consider the weight of those structural members, but here we will consider the weight of the structural members. That is why, so we will multiply the self weight with -1. So let us save it. So factor is -1, direction is y, so minus gives the negative direction, that is the downward direction. So click on add and close it. Now the 20 kilonewton point load here, 10 kilonewton per meter uniformly distributed load here, and 5 kilonewton meter moment here. We can either apply those loads as dead or the live. In the building, the dead and live loads are clearly defined. What load you want to apply as the dead, what load you want to apply as the live. But here in this example, you have the liberty to choose. So here we will apply those loads as the live loads. You can see that a question mark is here in the self weight, which means that we have told the software that we are applying the self weight, but where we are applying or in which structural member we are applying, we haven't yet told the software, which means that we haven't yet applied the load. So we'll do this in a while. Before that, let us define all the loads that we will be applying. So left click on live, and after that click on add. The first load that we are applying is the point load. So this is a member load that we apply on this member. So left click on this member load option here. So you can see that different options are available here: uniform force, uniform movement, concentrated force, concentrated movement. So uniform force is the UDL. So then we got the uniform movement. Similarly, we got the concentrated force, which is our point load. Similarly, concentrated movement, that is the point movement. Linearly varying force, that we will see in the next chapter. So left click on the concentrated force. The concentrated force we are applying is, the value is 20 and the unit is kilonewton. So here you can see the D1 and the D2. So D1 means that so this is our beam. Okay, so this is our beam, so this is the first point of the beam and this is the second point of the beam. So this is also known as the local axis. Okay, so for this beam, this is the origin and this is the final point. All right, so this is the local axis, and whatever we do in our model is the global axis. D1 distance means that at what distance from the origin of this beam, okay, not from the origin of the entire structure, but from the origin of this beam, you want to apply the load. That is your D1. Here we want to apply the load at a distance of 2.5 meters from the face of this beam, which means that D1 is 2.5 meter, and D2 means suppose if this is our center, from the center at what distance towards the face of the beam you want to apply the load. So we want to apply the load at the center, that is why D2 is equal to 0. So let us go to Staad Pro. So D1 here is 2.5 meters because we want to apply the load at 2.5 meters from the face of this beam. Okay, so this beam, the direction is GY, that is the global axis. This GY is positive and it is positive in the upward direction, which means that this load will be applied in the upward direction, but we want the load to be applied in the downward direction. That is why we will put a minus sign here. After that, click on add. So here you can see that we have added a concentrated load GY minus 20, that is downward direction, at a distance of 2.5 meters. Okay, next load that we are applying is the uniform force. So here the uniform force value is minus, because we are applying in the downward direction, 10 kilonewton per meter. So D1 is the distance from the face of the beam. So let me sketch this again. You can see that this is our beam. So suppose that you are applying a UDL at a distance 1 meter from the face of the beam. So from here you are applying the UDL, and the length of this UDL is, suppose it's 2 meters. In this case, so this 1 meter is our D1, this 2 meter is our D2, and D3 we know. So if this is our center line, and at what distance from the center line to the face you want to apply your UDL. In this case D1 is 0, so D2 also you can say it as 0, so which will mean that, so the software will understand that you want to apply this throughout, and D3 will also be 0, which means that we are applying the load at the center line of the beam. So we have said we are applying the load of minus 10 kilonewton per meter UDL. So all these distances are 0, and the direction is GY, global Y coordinate, and we click on add. So we have applied the load uniform GY minus 10 kilonewton per meter. So next thing that we are applying is the concentrated movement. So it is not a distributed movement, it is the concentrated movement. So left click on this. The value of the concentrated movement is 5 kilonewton per meter. Let us again understand the convention of applying the moment. So this is our beam. So this is our beam, okay, and we're applying the moment in the clockwise direction, all right, at the center. So this distance is the D1. So from this end, so this end is the your known as the I end, and this end is known as the Z end, okay. And in the node term you can say that this is node 1, this is node 2, just an example. So in our example this is node 3 and this is node 4, all right. Okay, so this distance is the D1 distance, and as this beam is of size 4 meters, in our case the d1 distance is, as we are applying the moment at the center, d1 is 2 meters. Okay, and d2 is at what point from the center line to the face you want to apply your moment. Okay, in Staad Pro, the clockwise movement is taken as negative and the anti-clockwise movement is taken as positive. So this is just an convention, so you have to remember this. Okay, let us give these information. So d1 is 2 meters, and as our movement is clockwise, so we will write -5. And also talking about the direction, so as I already told you, so this is our beam, and this axis is our x-axis, and this axis is our z-axis, and this axis is our y-axis. As you can see that this movement is being applied along the z-axis. Okay, I told you in case of y-axis, so if this is your axis and movement is acting like this, so which means that the movement acts about the y-axis, so perpendicular to the axis. Okay, so here you can see that this movement is perpendicular to the z-axis, which means that it is being applied on the z-axis. So we have to apply this about the z-axis. So gz -5, 2 meters, click on add. After that, close this.